Okay, so now moving on to the next question, we have the Neckwear Association of America reported that 3% of neckties sold in the United States are bow ties. Okay, so I'm going to go ahead and write this down, that the probability of being a bow tie, I guess I could have just written B there, equals 0.03. Okay, so if 4 customers who purchase a tie are selected at random, find the probability that at least one purchased a bow tie. All right, so whenever you see this at least one, you should automatically start thinking about complements. At least one should always trigger in your head, well, the probability of at least one is 1 minus the probability of none. Okay, so let me go ahead and write that down. So the probability that at least one bow tie, this is going to be equal to the 1 minus the probability of no bow tie. Okay, so all 4 do not get a bow tie, right? So no bow tie out of 4, right? Okay, so at least one bow tie, 1 minus probability of no bow ties out of 4, right? Whenever you see at least one, always think 1 minus none, right? In general, probability of at least one equals 1 minus the probability of none. Okay, this is a very important thing that you should always think about whenever you see that phrasing, at least one. All right, so now, how do I need to find the probability of no bow tie out of 4, right? So that means that the first person does not get a bow tie. So the first person does not get a bow tie, right? And the second person does not get a bow tie. And the third person does not get a bow tie. And the fourth person does not get a bow tie, right? None of the 4 people got a bow tie. So in other words, I could write this, if this is bow tie is B, right? Okay, then I could write this as B prime. Remember, prime means not B, right? That little sign here means not whatever the event is. So not B and not B and not B and not B. Okay? So now, using the multiplication rule, now these 4 people are selected at random. So that means that they are independent from each other. So this is the same thing as using the multiplication rule, first person not getting a bow tie, times the second person not getting a bow tie, times the third person not getting a bow tie, times the fourth person not getting a bow tie, right? So we just talked about in the previous video an example where you have independence and you're going to use the multiplication rule to figure out that probability. Okay, now you're seeing not bow tie 4 times there, multiplied 4 times. So that's the same thing as saying not a bow tie to the 4th power. So let me go ahead and write that, right? To the 4th power. So not a bow tie times not a bow tie times not a bow tie times not a bow tie is not a bow tie to the 4th power. Okay, so now I just need to find the probability of not getting a bow tie. So the probability of getting a bow tie, we've already discussed, is 0.03. So what's the probability of its complement, not getting a bow tie? Will be 1 minus the probability of getting a bow tie. This is 1 minus 0.03, which is 0.97. Okay? So this is kind of to the side, right? So then our probability of at least one bow tie, at least one bow tie, right? We've already determined it's 1 minus the probability of not getting a bow tie to the 4th power, which is 1 minus 0.97 to the 4th power, which is 1 minus 0.885, which equals 0.115, or 11.5%.